Hello everyone, I am Suputra Patta, Assistant Professor, Department of Computer Science and Engineering, BIDCET, Dr. PG Halkatti College of Engineering and Technology, Vijaypur. So in the last class, we have discussed something about key management, and in that we have discussed key life cycle, key hierarchies. So in today's class, we will be discussing managing the top level keys. So top level, or what you can call it as master keys, need to be securely managed or the whole key hierarchy is compromised. So master keys are commonly generated, established and backed up in component form. If a master key needs to be shared between two different HSMs, then one option is to generate the same master key from components separately on each HSM. So, an alternative is to run a key agreement protocol between the two HSMs in the order to establish a shared master keys. So here, how to manage actually the master keys along with that high level security management. That is what it all depends on the master keys. So scalable key hierarchies. There are two key distribution approaches to acquiring shared key from a KC. KC here is key center. So consider a simple scenario. In each case, let us assume that Alice, I think already I told you, there are three actors, Alice, Bob and Charlie. So Alice, Bob and Bob are the authorized users, whereas Charlie is the intermediate person where you can treat it as hacker or intermediate person. So in each case, let us assume that Alice wishes to establish a shared data key K with Bob. Also assume that both Alice and Bob have respectively established master keys KAC and KBC with the key center, and that a simple two-level hierarchy is being employed. The two approaches are, so here in this uh, the approach is what we need to maintain is key translation and key dispatch. So how to transfer, how to translate the key securely, as well as how to dispatch it to a authorized user. So let us discuss the first step in that is key translation. So in this approach, the key center simply translates an encrypted key from encryption using one key to encryption using another. So here what Alice does is Alice transfers its key, that is key AC, to key center, and from key center it is transferred to something else. I mean here very simple concept here. Bob and Alice transfers their keys, that is shared or master keys with the key center, and after that what we have is that particular key is encrypted using key AC, that is encryption of K AC, that is Alice key, so that will be transferred. Similarly, uh, the Bob's key will also be encrypted with what the key, that is what you can call it as a key translation. So both Alice as well as Bob should share their keys to the key center. So here what happens is, just I'll read it. You can see this. This approach, KC simply translates an encrypted key. KC translates an encrypted key from encryption using one key to encryption using another. In this case, the KC is acting as a type of switch. This process is depicted in the below figure as I explained. So Alice generates a data key K, encrypts it using KAC, this one, and sends this to KC. Similarly, KC decrypts the encrypted K using KAC, re-encrypts it using KBC, and then sends this to Bob. So how a KC, that is KC, acts as a switch here. Just you can see, Bob decrypts the key encrypted K using KBC. So this is what the how exactly we will be translating key securely. That is what the first concept here is, key translation. Second one is key dispatch. So in this approach, the key generates the data key and produces two encrypted copies of it, one for each user. So this process is depicted in the figure. You can just see here. So here very much similar. Bob and Alice translate its key, that is KAC and KBC to key center. And here what happens? It generates K. So here the encryption process is, so KAC is encrypted. K will be generated, that will be encrypted using KAC, or else KBC will be encrypted. K will be encrypted using KBC, that is of EKBC of K. And finally what we have is how the key is dispatched is E of KBC of K. That is how we can just dispatch whatever the key we want, that key will be dispatched. You can see here KC generates the data key K, encrypts one copy of it using KAC, only one copy of it using KAC, and another copy of it using KBC, and then sends both encrypted copies to Alice. Alice decrypts the first copy using KAC and sends the other copy to Bob. Bob decrypts the second copy using KBC. Very simple. So here Alice decrypts the first copy, whereas Bob decrypts the second copy. Next, what we have is a unique key per transaction scheme. You can call that as a UKPT scheme. Unique key per transaction scheme is a different way of establishing a cryptographic key, and they establish a new key each time that they are using. So this scheme is a different way of establishing a cryptographic key, and they establish a new key each time that they are using. So what is the motivation for this UKPT scheme? Previous key establishment mechanisms involves one or both of the following. The use of long-term, that is long-term or top-level secret keys. For example, the use of master keys or key encrypting keys in the key hierarchies. Second is a special transfer of data explicitly for the purposes of key establishment. This applies to every technique except key distribution. So next, the first requires devices that can securely store uh, and use long-term keys, and the second introduces the communication overhead. One of the reasons that most of the previous schemes require above mentioned features is that the new key that is being established has been generated independently. So in the sense that it has no relationship with any existing data. An alternative methodology is to generate new keys by deriving them from information already saved by Alice and Bob. If key derivation is used to generate new keys, then the processes of key generation and key establishment essentially merge. So overall, what you can say, all these factors bring some advantages. Alice and Bob do not need to store a long-term key. Alice and Bob are not required to engage in any special communication solely for the purpose of key establishment. Key generation and key establishment can be automated. So these are the advantages. So application of UKPD scheme. So one example, I'll be discussing that example. A good example, this example I will discuss in the next class. Thank you.